All right, now for meters to motors. The principal difference between a galvanometer and an electric motor is that in an electric motor, the current is made to change direction every time the coil makes half a revolution. Whatever all of that means, right? So let's get in and let's figure it out. The simplest meter to detect electric current consists of a magnetic needle. As you can see right here, this needle is magnetic, on a pivot at the center of loops of insulated wire. So what you know already is that as current goes through this wire, this needle is going to move. And then it's going to get through one loop, and then it's going to move the needle a little bit more. When an electric current passes through the coil, each loop produces its own effect on the needle. A very small current can be detected. A sensitive current indicating instrument is called a galvanometer. A more common design employs more loops of wire and is therefore more sensitive. The coil is mounted for movement, and the magnet is held stationary. The coil turns against a spring, so the greater the current in its loops, the greater its deflection. A common galvanometer consists of a stationary magnet and a movable coil of wire. A multimeter can function as both an ammeter and a voltmeter. So we have this one, a galvanometer, which detects the presence of electric current, very small electric current. And then we have a multimeter, which detects the current, ammeter, and the voltage, voltmeter. A galvanometer may be calibrated to measure current, or amps, in which it is called an ammeter. Or it may be calibrated to measure electric potential in volts, in which case it's called a voltmeter. So with an ideal ammeter should be placed in series of whatever circuit you're trying to deal with. The reason for that is an ideal ammeter, which isn't really true, but an ideal ammeter, if we assume an ammeter to be ideal, means that there is zero resistance. So if you place it within the current or within the circuit, it's not going to affect any of your readings. An ideal voltmeter has a resistance of infinite resistance for an ideal voltmeter. Because of that, we have to measure voltage in parallel. We have to create that junction. If the design of the galvanometer is slightly modified, you have an electric motor. The principal difference is that in an electric motor, the current changes direction every time the coil makes half a revolution. After it's been forced to rotate one half revolution, it overshoots just in time for the current to reverse. The coil is forced to continue another half revolution, and so on in cyclic fashion to produce continuous rotation. So after it goes half a revolution, it overshoots just in time for the current to reverse, so that way it's going to change direction. In a simple DC motor, a permanent magnet produces a magnetic field in a region where the rectangular loop of wire is mounted. The loop can turn about an axis. So this is your loop of wire. When current passes through the loop, it flows in opposite directions in the upper and lower sides of the loop. The loop is forced to move as if it were a galvanometer. You can make an easy one of these called a homopolar motor. And in that case, you attach a magnet to one end of a battery, and then you bend a paperclip around, and you should get some sort of motion. Because that's what a motor does. A motor transforms electrical energy into kinetic energy. Meanwhile, a generator takes mechanical energy, rotation of a magnetic field, and create or transforms the mechanical energy into electric energy. The current is reversed during each half revolution by means of stationary contacts on the shaft. The parts of the wire that brush against these contacts are called brushes. The current in the loop alternates, so the forces in the upper and lower regions do not change directions as the loop rotates. The rotation is continuous as long as the current is supplied. Larger motors, whether it's DC or AC, are made by replacing the permanent magnet with an electromagnet energized by the power source. Many loops of wire are wound about an iron cylinder called an armature. which then rotates and is energized with an electric current. How is a galvanometer similar to a simple electric motor? How do they fundamentally differ? A galvanometer and a motor are similar in that they both employ coils positioned in magnetic fields. When current passes through the coils, forces on the wires rotate the coil. The fundamental difference is that the maximum rotation of the coil in a galvanometer is 1/2 turn, whereas in a motor, the coil rotates through many complete turns. In the armature of a motor, the current is made to change direction with each 1/2 turn of the armature. Concept check. What's the main difference between a galvanometer and an electric motor? Hopefully you can explain that by now.